Alright guys, go ahead and begin here. So this is lesson 6. Lesson 6, I'm going to finish up what we didn't finish up last class, and then we're also going to squish in one other topic. So what we didn't finish up last class was calculating the period of a trig function. And after that, I'll show you guys how you can graph trigonometric functions with horizontal transformations when you're dealing with radians. Last class, you might have noticed that all we did was we worked with degrees. It's a little bit easier because you don't have to deal with fractions, but with radians, you know that a lot of those things are fractions. Also, the second part of this week is going to be your test. So let's go ahead and get started here. First of all, we talked about periods last class a little bit. What is a period of a periodic function? Well, what is a periodic function? A periodic function is basically a function that repeats. So you guys can tell by this shape here, this shape just repeats over the x-axis. Now the length of that shape that repeats is what we call a period. So in this case, the period from -3 to 2, that's a distance of 5. So we would say this periodic function is a period of 5 because the horizontal length from beginning of the shape to the end of the shape is 5. So this would have a period of 5. Now, usually with trigonometric functions, we've talked about two types here. Now, for the sine wave and cosine wave, as well as the cosecant wave and the secant wave, all of those have the same period. All four of those, when we graphed them, they always started at 0 and they ended at 360. So, like, just to graph a sine wave really quick, it looked like this. That pattern, before it repeated again, looked like that for sine. For cosine, it looked like this, and then it repeated. For cosecant, it would have looked something like this, I think. And then for secant, it would have looked something like this on that interval. Okay, so all of them, though, finished their pattern in 360 degrees. But there were two other ones that we talked about, tangent and cotangent. Now, tangent, as you might recall, tangent went from -90 to +90, and it looked like that. That's a period of only 180 degrees. Cotangent's the same. It also has a period of 180 degrees. It starts at 0 and it ends at 180. So that's still a period of 180. So tangent and cotangent have smaller periods. These four have a pattern that starts from 0 and ends at 360. These two both have a pattern that has a span of 180 degrees, and then they repeat. So tangent and cotangent have smaller patterns over which they repeat. So, and you guys remember also something we talked about with our horizontal transformations for their last discussion last week was that this number here kind of results, it's the main number that determines whether you have a horizontal stretch or compression. And because it stretches your graph or compresses it horizontally, that will result in a change in the period of your function. So for instance, if you have a sine wave that goes from here to here, right, usually from 0 to 360, well, if you were to put a number in here like 4, that's going to change your period. It will compress it, so it will be 4 times shorter horizontally. So it will change your period. So what I'm going to show you guys right now is how you can find what the period of a function is. A lot of times questions will ask, what's the period of the function? So I figured I'd go over it. It's not super important for us, but it's worth chatting about. And just so you guys know, I also teach how to graph these a lot differently than most. Matter of fact, I've never seen anybody teach these the way that I do. So if you guys are going on YouTube trying to figure out how to do this in a different way than I'm doing, you're probably seeing something very different. And I'll just caution you, the other strategy that you guys see on YouTube for graphing these things, it looks easier at first, but trust me, by the end, it's just as hard, if not harder. And then every year I get some students who think, man, Mr. Bailey, this is really confusing. I don't know what you're doing. I'm going to go ahead and I'm just going to not ask you questions, and I'm going to go look up how to do it a little bit differently somewhere else. And They always come back totally lost. So just stick with me here. I promise you what I'm giving you guys to do here, it's either A, easier because the steps are always the same, or B, it's going to be just as hard anyway. So just stick with me and do what I'm showing you. Anyway, so that's just talking about graphing though. But for now, for finding the periods, that's actually not too hard. It's pretty chill one way or another. And the reason I was bringing up the whole different ways of graphing these, because most teachers that teach it, the way that they teach graphing, it has to do with finding the period first. And so I want you guys to know how to find the period, but for the way I teach you guys how to graph it, you actually don't need to know that at all. But it's still a good thing to be aware of, so we're going to cover it. So how do you find the period of a trigonometric function? Okay, well, it all has to do with this number right here, as I mentioned before. It also has to do whether you're dealing with one of these 4 types of functions or one of these 2 types. Now, these 2 types of functions, these 4 types up here, they're usually 360 degrees, right? But the period will change based on this number, and the way it changes is by dividing 360 by that b value. Okay, but if you're dealing with tangent and cotangent, you'll divide 180 by the b value. Now, just so you guys know, that's just for degrees, though. For radians, the equivalent of 360 degrees is 2 pi. So if you're trying to find the period in radians, it would be pi divided by b, or the equivalent of 180 degrees in radians would be pi. So if you're trying to find the period in radians for tangent or cotangent, it's pi divided by b. So go ahead and take a look at a couple of examples here on how to do this. So for number 1 here, we're going to be finding the period in degrees. Now notice this is a tangent. Tangent is usually 180 degree period, but we're going to divide it by 4. That's 45. So what that means is that this tangent function will now complete a full cycle in only 45 degrees. I don't know what the starting degree is or the ending degree. That doesn't really matter. But what does matter is that tangent will complete its cycle, and the distance between the first and the last point will be 45 degrees total. So tangent will complete its cycle in only 45 degrees. Now let's do an example involving sine. Now this one's a little bit trickier. You have to rewrite this. Okay. Instead of writing this as theta over 3, I'm going to rewrite it as 1/3 times theta. Now the importance of doing that is so that you accurately know what your b is. In this case, your b, the b value that you're multiplying your theta by, is 1/3. It's not 3. Okay. B is the number that you're multiplying your theta by. But right now it's written like a division problem. So you're going to rewrite it as a multiplication instead. So theta over 3 is the same thing as 1/3 times theta, which means that your b is 1/3. So now that we've established that, let's go back to this. Sine usually has a period in degrees of 360 degrees. It completes the cycle in 360 degrees. But we're going to divide it by our b value, which is 1/3. How do you divide by a fraction? Well, the way we talked about this earlier was you multiply the top and the bottom by the little denominator, right? So multiply by 3 on the top and bottom. This 3 will cancel that 3. 3 times 1/3 is just 1, right? And then 3 times 360 is 180. It's going to be 1,080 degrees. So this function gets way stretched out. Usually sine wave will complete its cycle in only 360 degrees. But what happened is this one became 3 times greater. So now this thing looks really long. It got really stretched out. So now it completes its cycle in a lot more degrees. All right, we're going to do the same thing now, but we're going to do it with radians. So we're going to find the period in radians. Now usually for tangent will complete its cycle in, let's back up a little bit, pi radians, right? So we're going to do pi, and we're going to divide it by the b value, which is 2. And there you go. You're done. There's nothing else you need to do. It's usually pi, but we're dividing by b, which is 2. Let's take a look at the other one for cosine. Once again, we want to rewrite that. We want to rewrite that as 1/2 times theta so that we can accurately identify our b. Our b value in this case is 1/2. Now, cosine usually has a period of 2 pi when you're dealing in radians. So I'm going to take 2 pi, and I'm dividing it by the b value, which is 1/2. So I'm going to multiply the top and the bottom by 2, which gives me 4 pi. Okay, so that's how you can find the period of functions in radians and degrees. So here's some examples for you guys to mess around with. I'll let you guys try it. Pause the video here, and when you unpause it, you'll see this. Okay, so here are your solutions. This one is 60-degree period. You do sine is usually 360 divided by the b, which is 6, gives you. For number 2, we have a fraction one, so we have to rewrite it as 1/6 theta, which tells us that our b is 1/6. Cosine is usually 360, so 360 divided by 1/6. If you multiply the top and bottom by 6, you end up with 2,160. That is the period. Number 3, in radians, secant usually has a period of 2 pi, but we're dividing it by b, so it's 2 pi over 5. Tangent usually has a period of pi, and we're dividing it by 1/2. Because theta over 2, once again, is 1/2 theta, so that means our b is 1/2. So pi divided by 1/2, you multiply the top and the bottom by 2, you end up with 2 pi. So those are your periods of those particular functions. Okay, now we're going to get into graphing trigonometric functions, but using radians. Before we start, though, I want to make sure your guys' algebra skills are up to par for this. So we're going to be solving equations to do this that look a little bit like this equation you see here on this paper. So to do this, what you need to do is you want to get rid of those ugly fractions. So the first thing we're going to start doing is we're going to multiply everything by the denominators. Okay? So I'm going to start by multiplying everything by, let's start with the 3. Why would I do this? When you multiply a fraction by its denominator, then that cancels that denominator out. So now that one on the end there is just pi instead of pi over 3. Now for the next one, right here, nothing cancels. I've got a 2 on the bottom, and that doesn't cancel anything on the top. When nothing cancels, we're actually going to go ahead and multiply the numerator with the 3 then. So I'm going to end up having 9 pi over 2. Same thing happens here. Nothing cancels, so it's 15 theta. Okay. Since we still have a fraction, I'm going to do it one more time. This time I'm going to multiply everything by 2, though, so I can cancel out the 2. So times 2 here, times 2 here, times 2 here. And that's going to leave me with 30 theta. I did not write that. Back up a little bit. 30 times theta minus these cancel, so we're just left with 9 pi, and then 2 pi. Once all the fractions are gone, our goal is that we want to get the theta by itself. Okay, so the first thing we're going to do is we're going to put the pi's together. Oopsie. And then the last thing that we need to do is divide by 30. And we got our theta by itself. So you guys need to know how to solve equations like this in order to do the graphing exercises that are coming up later. So this is just a skill builder practice, but you got to make sure you know how to do it. So let's go ahead and do a student practice of this skill builder first. Let me give one to you. So why don't you guys go ahead and try to solve this one really quick. Pause the video and give it a shot. So here's the final solution for that one. Theta would be 2 pi. So the first thing I did was I multiplied everything by 4. So over here the 4 is canceled. 4 times pi gives me 4 pi over 2. And then 4 times pi gives me 4 pi. Now, at this point, some of you guys might have done something a little bit different. I just did this just in case some people did it this way. But in this case, technically, you didn't have to write 4 pi over 2. You could have reduced this and just been left with 2 pi and had a much easier job. However, some of you guys might have just left it like this because you're following my steps from earlier. In this case, you'd have to multiply it by 2 again. which is going to end up giving us the following. And then solving for theta from there would give you 2 pi. Okay, so make sure you know how to solve equations like that. If you don't get it still, you might want to go back and just mess around with a few. So what we're about ready to do now is we're going to start graphing trigonometric functions. But I'm going to basically do, we're going to end up doing all 6 trigonometric functions. I'll do one, you do one, I'll do one, you do one, I'll do one, you do one, and by the end we'll have graphed all 6 trigonometric functions. Okay, so let's go ahead and begin here. So for this week, you guys, I have included a summary worksheet of how to graph all the functions that we talked about: sine and cosine, secant and cosecant, tangent and cotangent. On all of these, I give you a picture of what your outcome should look like. I talk about degrees and radians, whether you want to do it one way or another, and then the steps on how to do it, including factors that affect, reflections and whatnot. So we're going to get a chance to go through each of these. So the first 2 things we're going to do is I'm going to do an example. You're going to do an example, sine and cosine, that involves these steps. Now today, we're only focusing on the radians, but all the same steps apply. Okay, so let's go ahead and we'll take a look at our first example here. Example 1. All right, so let's begin here. Notice we're dealing with a sine function, so I'm going to go to my little cheat sheet here, graphing sine. The first thing says find your theta values. Set the argument, that's the stuff inside the parentheses, equal to the theta values below and solve for theta. So since we're doing radians today, I'm going to set this inside portion equal to 0, and then I'm going to set it equal to pi over 2. And you can keep doing that for all 5 of them if you want. However, as we talked about last class, there's a pattern you can follow to find the rest so you don't have to keep doing that repeatedly. Okay, so for sine, our first angles are usually 0 followed by pi over 2. And I'm going to set this inside portion here equal to those first 2 angles. I'm going to transform my angle. Okay, so first thing I'm going to do is I'm going to multiply everything by 2. So if I multiply this by 2, the 2's cancel, so I'm left with theta. If I multiply this by 2, I'm left with 2 pi. And if you multiply 0 by 2, you just get 0. Next thing we do is we solve for theta, so I'm going to minus the 2 pi on both sides. And I end up with theta equals negative 2 pi. My starting angle for sine is usually 0, but now it's negative 2 pi. Let's repeat that for our second angle. My second angle here, I'm going to multiply everything by 2. So if I multiply this by 2, I'm left with theta. If I multiply this by 2, I'm left with 2 pi. And if I multiply this by 2, if I multiply this by 2, I'm left with pi. And now I'm going to subtract 2 on both. 1 take away 2 leaves me with negative 1 pi. So now this is where I'm going to use my pattern. Okay, if I'm going from negative 2 pi to negative 1 pi, that means I went up 1 pi. So if I just continue my pattern for the next few angles, 1, 2, 3, 4, 5, that means my next angle, if I go up again, if I add a pi to that, will be 0. And if I add another pi to that, I get 1 pi. And if I add another pi to that, I get 2 pi. So those are going to be the angles that I use. So that is the first step in the process of graphing these functions. So set the argument equal to the theta values given here and solve for theta. And if you can, use the shortcut to find the rest. All right, next thing we're going to do is we're going to identify the midline and we're going to sketch our midline. So let's do that. So first of all, let's set up our graph. We're going from negative 2 pi to negative pi to 0 to pi to 2 pi. Now we want to graph our midline. our midline is, well, to know that we kind of need to see the original equation again here, so let me bring that up. Okay, the midline is -1. So I'm going to put my midline here at -1. Okay, what do we do after we find our midline? After you identify the midline, you're going to identify the amplitude and use that to find the max and the min. All right, so this number here in the front is our amplitude. So I'm going to go up 3 from the midline. 1, 2, 3. And that's where I'm going to be putting the maximum. And then I'm going to go down 3, and that's where I'm going to be putting the minimum. Okay, next step. Use the guide below to determine which way to go. Now, since we're dealing with sine, I'm only going to be considering these 3 possibilities. Now, if we have just a normal sine, we'll start at the midline and go up. But if we have a negative inside or outside, we'll be doing one of these 2 things. Well, in this particular problem, all we have is a normal sine. There's no negative inside the parentheses, and there's no negative outside the parentheses. So when you have a normal sine, you start at the midline and go up. So I'm going to start down here at the midline, and then I go up to the max for the next angle, back down to the midline for the next angle, down to the minimum for the next angle, and then back up to the midline for the last angle, and that gives me my sine wave. And of course, we go ahead and continue it after that, and that's our final graph. I'm going to go ahead and give you guys one to do. I'm going to have you guys graph the following. All right, so a couple things to draw your attention to. Notice that this is a negative in the front. But for this problem, before I ask you guys to pause the video and try, I'm going to have you guys pause the video at 2 different phases in this process. The first phase is going to be where you find your angles. So go ahead and pause the video and see if you can find your 5 angles that you're going to use to graph. Okay, so setting your argument equal to 0 and pi over 2 results in our first angle being -2 pi. And the second angle being 0. I'll let you study the algebra there a little bit if you didn't get those. But you'll notice also that to get from here to here, that's going up by 2 pi. So the rest of them will also go up by 2 pi every time. So our 5 angles that we're going to use are from -2 pi all the way up to 6 pi, going by intervals of. So I would say pause the video here and see if you can now get the final graph. And here you guys go. So notice that my angles are on there, 2 pi, -2 pi, 0, 2 pi, 4 pi, and 6 pi. We start here at our first angle, and since our cosine had a -2 in the front of it, I'm not going to write the rest, but since it had a -2 in the front, we start at the bottom and go up, and that is according to the little worksheet here that I gave to you guys. When you have a cosine with a negative in the front, you start at the minimum and you go up from there. Okay? So we're going to move on to example 3, and that's where we're going to be practicing graphing a secant or a cosecant graph. So when it comes to graphing secant or cosecant, let's look at our sheet. It says graph the corresponding sine or cosine graph. So as you guys might remember, when it comes to graphing secant or cosecant, the first thing we do is we're going to think of this not as secant, but for secant, we're going to think of that as cosine. And if you're doing cosecant, then you'll think of that as sine. But for me, I'm going to be doing this one. I'll probably have you guys do the cosecant and sine pair next. So we're going to start by graphing this, which means that we're actually going to end up graphing this cosine wave using the same exact steps that we learned last time, because right now we're just graphing cosine wave. So first of all, we take the argument and we set it equal to 0. I don't like that fraction, so I'm going to multiply everything by 3. That's going to end up giving me negative 9 theta plus pi equals 0. Now I want to get theta by itself, so I'm going to minus the pi on both sides, and then I'm going to divide by a negative 9, and that's going to give me pi over 9. That's my first angle to graph. Now I'm going to find the next angle. Cosine usually starts at 0, but now it's going to start here. The next angle for cosine is usually pi over 2. So now I'm going to set my argument equal to pi over 2. So I'm going to multiply everything by 3 again to cancel out the denominator. I end up with this. And I still don't like my other fraction there, so now I'm going to multiply everything by 2. That's going to give me negative 1/18 theta plus 2 pi equals 3 pi. I'm going to minus 2 pi on both sides. And then I'm going to divide everything by negative 18. So I end up with negative 18 over pi. Now, we have a little bit of a different situation here than usual. It's going to be hard to find the pattern here. If I asked you guys to find the other 3 angles, now there's 2 ways you guys can go about doing this. One way is once again, you can just set this equal to the other 3 angles of cosine, which are pi, 3 pi over 2, and 2 pi, or you can look for the pattern, okay? Now, for this pattern here, it's a little bit harder than usual because we're dealing with fractions. So let me show you guys how to find the pattern here. So my first, actually, let me bring back my equation really quick. I want to keep the equation there. So the first angle was pi over 9, and the next one's negative pi over 18, and I need 3 other angles after that. But if you want to find a pattern involving fractions, you need to have them with a common denominator. So what's the common denominator for 9 and 18? It would be 18, right? So I'm going to multiply the top and bottom by 2. So that's going to give me 2 pi over 18. And now I have a little bit better of a way of looking at this pattern now. This is negative 1 pi over 18. So now, to find your pattern, you really just look at the numerators after you've got your common denominator there. So if I'm going from 2 pi to negative 1 pi, then I went down by negative 3 pi in the numerator. So, because to go from 2 to negative 1, that's going down by 3, right? So if I go down by 3 again, that puts me at negative 4 pi, right? And then if I go down by 3 again, that puts me at negative 7 pi. And then if I go down by 3 again, that puts me at negative 10 pi. And we want to reduce these where possible. Okay, so let me erase here. So 4 over 18 reduces, I'm going to write this in black. 4 over 18 reduces in negative 2 pi over 9. 7/18 doesn't reduce, so that's just going to stay the same. But 10 over 18 reduces, and so this is going to be 5 pi over 18. Now, before we erase this stuff, I just want to show you guys something. You're noticing that it's going down every time, right? So we're going here, and then we're going down by 3 pi over 18 every time. We're going down by 3 pi, and our denominator is 18. So every time my pattern is I'm going down by 3 pi in the numerator, my denominator is 18, right? Well, if I'm going down every time, where's my highest number? It's kind of hard to tell when you're dealing with these weird, ugly-looking fractions. But think for a minute. I've got 5 numbers up here written in the form of radians. Which one of these numbers would be my highest number if I'm going down every time? The highest number would be this one. The lowest number would be this one. So what that means is that when I graph these, this number is a positive number. That's going to be on the right side of my graph. And I'm going to be going down, which means I'm moving left until I get to this number. So I'm going to start at pi over 9 on the right, and then my next number on the left of 0 is going to be negative pi over 18. So let me show you what that looks like. It's hard because, we're dealing with these weird, ugly numbers that don't really mean much to us. But let me show you. So we've already established that pi over 9 would be a positive number, and it's on the right. That's my biggest number. After that, though, we end up with negative 18 over, negative 18 over pi, right? Or negative pi over 18. Then after that, we had negative 2 over 9. Then after that, we had negative, sorry, I'm trying to remember these numbers. I kind of forget what they are now. What was the other one? Negative 7 over 18. And then the last one was negative 10 over 18. It was negative 5. It's supposed to be 5 from the. Okay, I think that's right. 5 pi, negative 5 pi over 9. Okay, so it kind of, since we were dividing by a negative, it kind of reversed everything around. So the first number I got is actually the one that's on the right up here, and then my last number I got goes over here. There's that. So what was my original function here? So we had 2 secant negative 3, right? Okay. And we were actually in the process of graphing cosine, actually. So let's review a little bit what we've done first here. So the first thing I did was I set all these equal to the usual angles for cosine, which if you need to see the sheet, I can show you. The usual angles for cosine, sine and cosine, are 0, pi over 2, pi over 2, and 2 pi. I just set it equal to the first two and solved, and then I used the pattern to find the other ones. And by doing that, I ended up with these 5 angles. But notice I'm going from left to right because this was the first angle I found, but it was actually bigger than the last one I found. All right, the next thing that we're going to do is we're going to graph our midline. Now notice I don't have a plus anything after the parentheses here. So that means my midline is the x-axis. The next thing I'm going to do is I'm going to use my amplitude, which is 2. I'm going to go up 2 spaces to find the max. Down 2 spaces to find the minimum. And now we're dealing with cosine. Now a cosine with a negative on the inside. Notice that we have a negative in front of our theta. Let's see what that does to our graph. It may not do anything or it may do something. Let's see. Whenever you have a negative in front of your cosine, you start at the maximum and you go down. So for negative 5 pi over 9, I'm going to start at the maximum, and then from there I'm going to go down. So my graph would look like this. Just so you guys know, when I'm grading these, the things I'm going to be looking at is, did you get the angles correct? And then I'm going to be looking at, did you have the right starting point and go in the right direction after that? Okay, so that's pretty much all I can look for. But as far as getting the angles, I would want to see your work on where these angles came from. And I almost forgot, for this particular problem, you guys may have noticed a weird shift on the screen. That's because I actually forgot to do this and had to come back and redo it. Is I forgot to actually graph what we were trying to graph. Remember, what we're looking at right now is just a picture of cosine. But we want a picture of secant, right? So I want to graph this secant graph. Now, remember, secant, anywhere where your cosine graph touches the midline, you're going to have a vertical asymptote. And then you put these little parabolas in there in between the vertical asymptotes, just like that. So the pink graph is actually what we would expect to see. All right, I digress. So let me throw one of these at you guys and see how you do. Okay, so once again at this point I would encourage you guys to go ahead and start this problem on up. Notice it's cosecant, and also notice that there is a negative here that's going to affect some things. But the first step is to find the angles. So go ahead and pause the video and see if you can find the 5 angles that we need to graph this function. And when you guys have it unpaused, I'll show you how I got the angles myself. Okay, so for my first angle, you guys, I get pi over 12. And for my second angle, I get negative pi over 6. Now you know there's 3 other angles we need to find. To do that, you need to get a common denominator between these. So see if you guys can figure out what the other 3 angles are. Once again, you can do this in 2 ways. You can just get a common denominator and use the pattern, or you can just set the argument equal to the other 3 angles of cosecant and go from there. But, oh, and by the way, when you're graphing cosecant, you know we're dealing with sine first, right? So you're thinking of this as a sine wave. All right, but anyway, at this point, find the other 3 angles either by setting the argument equal to the other 3 angles of sine, or use the pattern by getting a common denominator. I'll pause the video here, and you should too, and give it a shot. So here's the final answer. Our first 2 angles were pi over 12 and negative pi over 6. I got them to have a common denominator here. If you take this fraction and multiply the top and bottom by 2, you get 2 pi over 12. And then you can see we're going from a positive 1 to a negative 2 in the numerator. So that means we're going down by 3 pi in the numerator with a denominator of 12. So to go from 1 to negative 2, that's going down by 3. So every time we're going down by 3 pi over 12. Okay, I'm not going to write the rest, but they're all going down by 3, down 3, down 3. And then I put them up here, and if they needed to be reduced, I did. So the 11 over 12 and negative 5 over 12 don't reduce, but this one here does reduce. It becomes negative 2 pi over 3. So the next thing we're going to do is we're going to go ahead and graph this. Now, you got to remember, when you're graphing this, this is your biggest number, and it's positive, so it goes on the right of 0. And then after that, you're going to be putting these numbers going to the left on your graph. So go ahead and put it on there, see if you get it right. And this is how you guys would have placed it. Since this is a positive pi over 12, it's to the right of 0. All the other ones are negative, so they're to the right of, or to the left of 0. And we're going in a backwards fashion since we're going down. So this is negative pi over 6, negative 5 pi over 12, and so on. The last number, 11 pi over 12. And from here, we're going to graph the sine wave. So go ahead and do that. And then after that, graph the parabolas to get your secant, and then you'll see the final answer next time you unpause the video. Okay, so we have a midline of 0. Oh, I forgot. There's a negative 1 there. Poop. Oh well, I have the wrong midline. I put mine at 0, so your guys' will be the same, but just shifted down 1. Anyway, I'm going to leave it. But I have an amplitude of 1, so I'm going to go up 1 and down 1. There's my max and min, and then I go ahead. So your guys' max and min, just so you know, will be at 2 and at 0 instead of at 1 and negative 1. And then here's the big thing I want you guys to pay attention to, though. It's the fact that we have a negative in front of our theta. And when you have a negative in front of your theta, with sine, which is what we're graphing, a negative in front of your theta, you start at the midline and you go down. So you'll notice that for me, I start at my midline, which is 0, but for you it would have been negative 1. So you should have started negative 1, then went down to your minimum, and then back up to your midline, then back up to your max, then down to your midline. So your sine wave should have went like that. And then the green little parabolas that I put on there, those are the actual cosecant graph that you see at the top. So that's the end of that one. We'll do one more type of problem for you guys. So far we've reviewed graphing sine and cosine. We reviewed graphing secant and cosecant. And now we're going to talk about tangent and cotangent. Now, when you're graphing tangent and cotangent, it's a little bit tricky. You have to pay attention to the angles a little bit more carefully. For tangent, your angles are these. For cotangent, your angles are different. Okay? So let's go ahead and get started here. So I think I'll graph a tangent, and I'll let you guys do the cotangent. So let's suppose that I wanted to graph a a negative 1/2 tangent of 2 theta plus pi. Okay, so once again, the first thing you got to do is you've got to find your angles. Let's look at our steps on how to graph tangent. So the first thing we're going to do is we're going to set the argument, the b theta minus h, that's the 2 theta plus pi there, equal to our theta values below. Now, since we're doing radians, I'm going to use these. So the first angle I'm going to use is negative pi over 2. The next one I'm going to use is negative pi over 4. Now, this is, I'm going to pause here and be careful. So far, we've always been using 0 and pi over 2, right? But this is different. Tangent and cotangent have different starting angles. For tangent, it's negative pi over 2 followed by negative pi over 4. For you guys, I'm going to give you guys a cotangent one. You're actually going to set yours equal to 0 first and then pi over 4. So it's a different set of angles for those two sets. Anyway, so for tangent, I'm going to set 2 theta plus pi, the argument. I'm going to set that equal to negative pi over 2 first. And then I'm going to do the same thing, but I'm going to set it equal to negative pi over 4. Okay? So, different starting points for tangent and cotangent. That's an important thing to pay attention to. But the rest of it's pretty much the same after that. So I'm going to multiply everything by 2. Minus the 2 pi. And divide by 4. So I end up with a new starting point of negative 3 pi over 4. Next one, multiply everything by 4. Minus the 4 pi on both sides. Negative 5 pi over 8. And then I'm going to divide both sides by the 8 to get the negative 5 pi over 8. And then I have 3 more angles to find. Notice that they have 2 fractions with uncommon denominators. So I have to go through that whole gambit of getting a common denominator so I can find the other 3. And hopefully you guys are starting to feel a little more comfortable with this so that we know that we need to get a common denominator. Now the lowest common denominator for those first 2 fractions is 8, right? So I need to multiply the top and bottom of this fraction here by 2. And then I can start seeing what my pattern is. Well, as you can see, my numerators are going down or going up by 1. If I'm going from negative 6 to negative 5, I'm going up. So the next one would be negative 4 pi over 8, negative 3 pi over 8, and negative 2 pi over 8. But now I'm going to go ahead and reduce those. So this one reduces to be negative 2 pi over, it's actually, let me back up a little bit. That reduces to be negative pi over 2. I can reduce it by 4. The next one does not reduce. The last one reduces to pi over 4. And notice that since we're going up this time, right, we're actually increasing. To get from here to here, I went up by pi over 8. That means this is my smallest angle and this is my biggest angle. Okay, so that means this angle here, the 3 pi over 4, that's going to be farthest on the left, and this one will be farthest on the right. But all my angles here are negatives, though. So everything's going to be to the left of 0. But this one is the farthest left, this one's the farthest right. So what would that look like if I went through and graphed it? And there you go. So negative 3 pi over 4 is the farthest one on the left, negative pi over 4 is on the right, but all of them are to the left of the y-axis because they're all negatives, right? So, what's the next step after we find our angles? Sketch the vertical asymptotes at the first and last theta values. So I'm going to sketch a vertical asymptote at the first theta value and at the last theta value. What's the next thing we need to do? Plot the midpoint. In case you guys forgot how to do that, let's review that as well. So the k value tells us how high up the midpoint should be. So since I don't have a k value here, it's 0. So my midpoint is going to be right at the middle angle on the x-axis. If I had like a 2 here, I would take this dot and go up 2. In this case, since it's not there, I'm going to put it right on the x-axis. The next thing we're going to do is, let's take a look, is we're going to use the stretch factor to plot the adjacent points according to the diagram below. So whatever the A value is, you figure out what the A value is, basically the amplitude. Whatever the amplitude is, we're going to use that. Now, if I have a tangent, a negative cotangent, or a cotangent, it'll look like this. But if I have a cotangent, negative tangent, or tangent of a negative theta, it'll go like this. So let's look at our graph here. I have a negative in front of my tangent. So when you have a negative in front of your tangent, that would be like this one right here, right? So my graph is going to be high on the left, and it's going to go down as we move right. All right. Now, what's the A thing all about? This is stuff we've already learned. I'm just refreshing your memory. Well, this number here is your A. It basically tells you what your amplitude is. So that means I'm going to go left 1 and up a half. So if I call this 1, I'm going to go left 1 and up a half would be about halfway up to the 1. And then I'm going to go right 1 and halfway down to a negative 1, which would be like right about here. Okay? And notice the direction I'm going, because when you have a negative in front of your tangent, your graph starts high and goes downward as you move left. And then from here, we kind of give it a little bend this way, a little bend that way, and then we just kind of stretch those lines up toward the asymptotes after that. So there's our final graphs, and you go ahead and repeat the pattern after that, and you're good to go. Now, for your guys that I'm about ready to give you, it's going to be a cotangent, but that'll change. So before you guys even begin this problem, I want to point a few things out to you. It's cotangent. So that means you're going to be setting the inside here, right? You're going to be setting that equal to what angles? Well, since we're doing radians today, you're going to set it equal to 0, and after that, you're going to set it equal to pi over 4, and you're going to solve both. After that, you can use the pattern to find what the other 3 will become. The other thing I want to point out to you guys before you begin the problem is notice that I have a negative in front of my angle. So when you have a cotangent with a negative in front of the angle, that would be this one right here. So your graph is going to be going in this direction. Okay? So, and a third thing I'd want to point out is notice that you guys do have a k value, which is -1. So your midpoint is going to be down -1. Okay? But anyway, we're going to do this in pieces anyway. So the first thing I'm going to encourage you guys to do is go ahead and find your angles first. So go ahead and pause the video and see if you guys can find it. So you guys will notice that I took my argument here and I set it equal to 0 and pi over 4, because when you're dealing with cotangents, those are the first 2 angles you use, 0 and pi over 4. Okay. The next thing that we did from there is we solved for theta. So my first angle came out to be pi over 3, and my next one was pi over 12. But we still have to find the other 3. Okay, so let's go ahead and do that. So when you have fractions, you got to get a common denominator. So the common denominator for 3 and 12 is 4. I'm sorry, 12. So I'm going to multiply by the top and bottom by 4, which gives me 4/12 and 1/12, right? Now, as you guys can see, then we're going down by 3 pi in the numerator every time, which means that my next one, if you take 3 away from 1, you're going to end up with -2 pi over 12. If you take away 3 again, you get -5 pi over 12. And if you take away 3 pi again, you get -8 pi over 12. And as soon as you got 5, you can stop. But now we want to reduce all these, if possible. This one reduces to be -pi over 6. This one does not reduce, so it's going to stay the same. And this one reduces to be 2 pi over 3. Now, something I want to draw you guys' attention to for yours is the fact that you have 2 angles that are positive. So these 2 angles here are positive angles. So those are going to be to the right of 0. And you have 3 angles that are negative, so those 3 angles are going to be to the left of 0. And I also want you guys to notice that you're going down, right? So this is your highest number. This one you're going to start with on the right, and then you're going to be going down towards the left as you go. These two will be to the right of 0. These three will be to the left of 0. So go ahead and see if you can plot those on your x-axis correctly. Pause the video here and see if you can do that correctly. And so there's our setup, you guys. Notice I've got these two, which I said would be positive. They're on the right side of 0, just like I said. And this one is the biggest number, because we're going down every time, right? So that was the one that's farthest on the right. After that is pi over 12, and then pi over 6, negative pi over 5 pi over 12, and negative 2 pi over 3, with these three numbers being to the left of 0 because those are negatives. So that's the correct graphing there for getting those on there. Now we're going to continue graphing. So at this point, you're going to plot your midpoint. You're going to use your amplitude to find the other 2 points, and you're going to connect your cotangent curve. So in other words, we're pretty much done here. So pause the video and see if you can get the rest of the graph on your own, and then check your answer. Okay, so notice that I'm at my middle angle, which is negative pi over 6, and I'm down one space because my k value there was negative 1. Notice also the direction. It's increasing left to right. Whenever you have a cotangent with a negative inside or with a negative outside, it increases this way. Second of all, my amplitude was 2. So as I went over one angle, I went up 2 spaces. Now, some of you guys might have accidentally put your dot here on the y-axis. That's wrong. The reason that that is wrong is because, sorry, I got a little distracted. My daughter fell and hurt herself. Anyway, back to where I was. Some of you guys might have put your dot right about here, and that's wrong because 0 was not one of our angles, right? We went from negative pi over 6 to positive pi over 12. So there's no 0 angle, so you're not going to put a dot here. So whenever you go over one space, what I mean by that is you're going to go from one angle to the next angle. So over 1 up 2 would be right about here, and then left 1 and down 2. And then you put dots, and of course, go ahead and continue the pattern in the other side. Okay? And that's pretty much it. So what I did for you guys in this video was I showed you how to deal with radians, which is a little bit of a pain in the butt because there's a lot of fractions involved, and it's also hard to graph because when you're looking at weird, ugly fractions and negatives and stuff, it's kind of hard to know where they go. So, but we do have a nice little cheat sheet here to kind of help us know how to graph all of these. So your next assignment, you guys, is going to be a test. This video will be a nice little way for you guys to kind of get used to dealing with, graphing all the different types at once, which is basically what you're supposed to be. But anyway, hope that was helpful. If you guys got any questions, of course, feel free to let me know.